welcome our first speaker to the stage today. And I'm very glad to introduce to you a colleague of mine. Her name is Agnieszka Czyzewska. And Aga's been working with eyeo for several years already, and she's held several roles in QA engineering. And she then progressed on to becoming the engineering lead in the extensions team. And nowadays, she's still working as software engineer in the development of our apps. A few other questions about Aga. She is very passionate about building great products, and she's known for her knack on improving even the most well-built systems. She is a specialist in JavaScript, but is always looking to expand her skills. And Aga's presentation will explain how eyeo basically ensures the reliability of its app logging extension in production by monitoring its health and logging the crash data. And Aga also brought a lot of practical examples. So please welcome to the stage, Aga.
Hello, everyone. 2 years ago, I had the pleasure presenting many of you how we at eyeo test our core of the extension, all through the automated tests. Today, I want to show you the other side of the coin. It's not about how we build it, but how we validate it in the world, how we ensure that our extension is working right now for millions of our users. I will be talking about proving the extension healthiness, mostly focusing on the Manifest V3 Chromium browser extension, but some of the practices are also valid on other environments and on other browsers. So to make it easy to follow the thinking that I wanted to present today, I structured today's presentation into 3 key areas. First, I want to set the baseline. I want to show you how I understand what working software means, what it means for the web extension, ad blocking web extension. And I also want to talk a bit about the challenges that web extension environment brings. Then I will show you the production health monitoring stack that we have at eyeo. And at the end, I want to bring it all to life and show you the case study, the example, how we put this monitoring stack together and how we make sure that everything works. And of course, at the end, I have some time for opening the stage for questions, when I'm looking forward to answering questions you might have after the presentation. So let's start from the beginning. What working means in terms of the software differs depending on the purpose of the software. So for the banking application, it will be accuracy of the transactions. For video streaming, it will be probably no buffering time, no errors on the user side. But for the extension, the definition of the working software is much more vague. It's much more focused on the user experience of absence. User expect the silence. For me, working at Blocker is the silent partner. It's the seamless protection layer that provides me clean browsing experience where I never have to fix any page because the ad blocker broke it, but I also don't see annoying ads. So if we go deeper into the topic of the silent partner, we could identify 4 key areas that we could, or 4 metrics that we can look at the extension depending on how we want to define it. So first one is, of course, effectiveness. We have to have high ad blocking rate. We have to block as many ads, as many annoying consent buttons as we can. Then we have accuracy. We also need to make sure that the extension blocks only the things that it is designed to block. So no blocking add to cart button on the e-commerce site, or no blocking the critical information that the user needs to see on the page. Then we have performance. So extension has to be ghost. Extension shouldn't introduce any noticeable slowdown. And last but not least, the stability. Of course, we wish our extension or our software wouldn't crash, but of course, crashes occur. So when they occur, extension should, first of all, inform us about it so we can avoid the situation in the future. And of course, on the user side, extension should gracefully recover. This would be very easy to track or measure if we would be on the server environment, but our extension and all of the extension are running on the millions of users' machines, different machines in the browser environment. And that brings challenges. First one, specific to Manifest V3 is service worker restarts, blackout. So service workers are put to sleep to save the resources. And because of that, we lose connection to the extension. We need to persist the state, and we need to also persist the data that we need for debugging or diagnostic if something goes wrong. Then second one is the uninstall mystery. So whenever a user clicks uninstall button on the browser, the connection is immediately severed. We don't have time to gather the data back. We can try to be creative to collect that in advance, but what if the service worker restarts happen in the middle? Then we lose everything. So we cannot also ask user directly. We could through the uninstall page, but it's not the way to gather all of the diagnostic data because user won't provide it because that would require technical knowledge. And last one is we have limited API control. On the server, we can log in, we can collect all of the diagnostic data about the memory, about the storage, about everything. In the browser environment, we are limited. We have to use API to get the state of the browser to be able to diagnose the problem. All of those challenges and all of the metrics that I've mentioned before made us in eyeo create our own solution. And it's not a solution that is only on one pillar. We have 4 layers of monitoring system in place. First one is the filters monitoring. Filters, the brain of our extension, telling us what to block, mostly are used by the ones that are mostly used by our users are the ones that are maintained by the community. And we have the responsibility to also ensure that they are healthy when they reach out to our users. The second layer is our own extension monitoring in Sentry. So this time we are monitoring the muscles, the code that is blocking or not blocking and deciding what to do with the filters that it gets. So here we have third-party tool, Sentry. But sometimes Sentry is not enough. So we put in place our own granular logging system and feature flag system to avoid the situation when we apply the fix and the fix is not working and we don't have easy way to revert it back. And most critical one is, of course, feedback from our users. We have user reports. We have option to gather diagnostic data through the button on the extension, and we can gather these user reports on our side. I will be focusing in the presentation on 3 layers that are automated, but I feel like the user reports and user eyes and ears on the edge are very important to close this feedback loop. So I wanted to include it to also bring a bit more attention to this part of the system. Okay, let's start with the first layer, filters monitoring. And I will share a bit of memory. 4 years ago, right after I joined eyeo, it was a huge hassle. It was a huge hassle because basically ad blockers broke the internet. The problem wasn't in the engine of one extension. The problem was with one bad filter rule that ended up being on the filter list that all of the users are using. There was a lot of hassle around it, a lot of uninstalls on the ad blocking on the ad blocking industry, a lot of misinformation regarding why it's happening. Basically, the blocking was happening on the Google Docs. So for most of the people, internet died. That was the main outcome of the information that we received. So we had to make sure that won't happen again. And we introduced 2 ways of monitoring the filters on our side. First one is the filter scroller. Every time new filter lands on the filter list that our users use, the crawler goes against 10K of critical domains. And if it finds at least 200 sites or domains that are broken, it raises alarm to our filter list team. And they identify the issue, they decide what action should be taken. Usually they patch the issue, and in the meantime, they reach out to the filter list authors with the suggestion what can we do better or what can be improved. The second tool that we have is the filter list validator. Our extension, the core of the extension, is designed in a defensive way. So whenever there is invalid filter, extension just ignores it and don't do anything with that. So no harm for us and for user. But of course, that reduces the effectiveness I've been talking about at the beginning. So we also need to make sure that the filter lists are as reliable and as effective as we can for everyone. So on a quarterly basis, our team is running the filter list validator and identifies the filters that are invalid, and then reach out to the filter list communities with the suggestion of what can be improved and what can be maybe changed, depending on what is the issue that we identify. Let's zoom in into the second layer of the monitoring, checking how our extension works. Sentry is the third-party tool we use for monitoring if any issues or any exception or any instability is happening in our extension. We treat it as a smart fire alarm. Whenever there is an issue, we get a notification, and we get also a bit of the diagnostic data. Of course, everything privacy friendly, no privacy information about, no private information from the user, but we get at least most critical information, which is how many events, how many users, what browser, which release, is it recurring, is it regression, maybe something new. That gives us also insight which line of code throw. This is just example of one of the issues we had, but which line of code is throwing the error. This way, we can easily start investigating the issue more deeper. But of course, that's not enough for us developers to know that, well, one line rejected or thrown an error. So we need to have more data. That's why we implemented our own logging system. This logging system is turned off by default. We turn it on only when we need it, and we turn it on only on a specific module for a small percentage of users, just to gather the sample data. We don't gather any personal information. We gather only the diagnostic of the state of the extension, and only on module that we are interested in. And whenever we gather data that is enough for us to move to the fixing, we just turn it off. So this way we avoid collecting massive firehose. We collect surgically selected sample data that allows us to proceed with the fix. Okay, now the time to bring this all to life and show you the case study. I think that will be the most interesting for everyone. So the issue I want to talk about is the one of the most complicated ones that we wanted to tackle so far. We needed to tackle so far. And it started when we had some user reports that the blocking doesn't work in the extension. Very wide reports, so it wasn't easy to identify which blocking doesn't work, but we had some fire alarm already. Then in Sentry, we had a couple of issues in the same time happening. We saw that there are issues with non-unique rule IDs. We also saw that there are issues with exceeding rule counts limits. And also, we got some errors while we are trying to interact with the browser API, the API that was related to the DNR rules. So we started looking deeper, and the team had the presumption that probably the issue is that the state of the extension, the state that extension thinks the browser is different than we think it is. Then it's in reality in the browser. So basically, the problem was that we presumed is that we might guess wrongly or create wrongly the IDs of the rules that we are handing over to the browser in the DNR. So the filters we were trying to add got not unique ID, and that's why we got problems with the DNR API. But that was only a theory. We need hypothesis. We need to have data-baked facts. So we introduced logging. We enabled it around interaction with the DNR API. We enabled it only for small percentage of users, and we started to gather data, what is in the extension, what we think is in terms of the rules and IDs of those rules, and what is in the browser API itself. And the data that we got after only 24 hours of logging was staggering. 60% of the users that had the logging enabled had a mismatch between their stored DNR rules and what our extension thought was there. And what was more considering was that 1% of our users had up to 30K extra rules, which means that it totally saturated the browser quota. And blockings, it was working on the old rules, but we couldn't apply next updates, and that made the blocking stop working because we couldn't apply new filter from the updates. So what we did, we decided to check the code, make the fix in the DNR. The idea the team had was that extension has to detect the mismatch. That's the first. We already detected it. We see that there is the mismatch. Then extension has to wipe all data from the browser, recreate it from scratch, and get a consistent state between extension and the browser. We rolled it out behind the feature flag because it was very, very critical feature, so we didn't want to roll it out to 100% of the users. And it worked for 80% of our users. For 20% of our users, we saw that there was constant triggering of the fix because of the service worker restarts. And that was impacting the performance of the browser and performance of our extension, and also impacting the uninstall rate on our site. So we turned off the experiment, and the team started fixes with more robust approach, making sure that race conditions are removed and everything else is working smoothly. Then with these deeper fixes, we again rolled it out to 62,000 of users. And this time, once we confirmed that the fix is working for 100% of the users, we decided to deploy the fix for 100% of users fully and remove the experiment and keep it as a stable state. And it was 2 months later after we started the investigation of the main root cause on our site. So we needed also the final proof to make sure that we indeed fixed the issue, because that was only from logging system, but the sentry was the fire alarm that we got at the beginning. So as you can see here, those are 4 issues that we identified at the beginning, and we expected at the moment of the fix that the number of the issue will be decreasing. In some of the cases, we still have the tail because of the user not updating the browser, or sorry, the extension in the browser, or there were also some other stuff that we were looking at, but mainly we confirmed that the fix was working and that the fix is stable and decreasing the problem on the user side. So as we conclude, I want to bring us all back to the core of what we do. And I summarize it here with this small text. Our mission is to bring users the silence they expect. And that's invisible by design. But this silence, the silence and this invisible by design is not built on the assumption. It has to be, the silence has to be proved real with data, and that's proved by data. At eyeo, we build our system to monitor the healthiness of extension and make sure that we not only identify the issue, we only have a tool to debug it on production, and also we have a tool to confirm that the fix that we landed is indeed working. And that's proven by data. So as you saw today, for us, the silence can be sometimes loud. And with that, I'm happy to open the stage for the further questions.
Thank you for the talk. Really interesting. So I'm curious about that. The first part, you said you were using automatic crawlers to detect broken sites and basically broken filters. And I was wondering, how exactly do you detect a broken site automatically? Like, what does it mean?
Well, this part of the solution is maintained by the filter list author, so I might not be the perfect person to answer it very deep. But if I understood everything correctly, is that we compare the visual like the screenshots of the page with what we have, and we also have some algorithm on top of that to make sure that what we see is indeed what we expect, because of course web is constantly changing. We are using the real pages, so sometimes we are using selectors, sometimes we are using the screenshots. But I'm happy to share like details or maybe contact to someone who could like show it more in advance.
Yeah, I think it's just a very intricate problem, and there's a lot of nuance, like and with filters as well. Like, how do you really know that it's if it doesn't trigger, it doesn't mean it never triggers, right? Or like,
Yeah, that's why when we run it on every change on the filterless site, we have very constant feedback. And if it doesn't trigger now, it could trigger later, but we are like, it's like with automated testing and very short feedback loop. We already get the feedback that it's working, and in the next commit or in the next filter update, we see that it's not working. So we have only like 2 changes or maybe 3 changes to investigate. That's why the human factor is still important to have here, to take a look, investigate, to reach out to the filterless authors, to understand how to mitigate that situation. But this is, as with Sentry, it's a fire alarm, and we need to then do an action on that.
thank you. Oh, well, it's not open source, by the way, is it?
The tool for crawling, I would have to check, because it might be. I will check and let you know.
Thank you.
Regarding the when if a filter list author decide to make a major change that hits the DNO, how quickly does that pick up on said change? Say for example, we made a change that removed or added 10K filters, and just like either an addition or a clamp. How soon does the system pick up on that to realize that they need to update the extension or such? Because I think there was obviously an incident relatively recently when we hit a said limit on MB3. How soon does the tool pick up on a change like that, for example?
So in terms of the updating the extension itself with the rules, if I understood that correctly?
Yeah, so if we made an update which essentially stops the extension from getting new lists, but the DNR limits being hit, how soon do you get alerted on said change, and when does that obligate to, I guess, a new extension update, for example?
Well, we do extension update every 2 weeks in terms of having the baked-in update of the filter rules, but we also have the div updates mechanism in the extension. So we dynamically use this 30K rule limit for updating to the newest version of the filter list. So basically, when the issue happens itself, like if you would hit the limit, then we are informed immediately by Sentry. But of course, in this case, we had a bug that we had to fix first. But now, if you would, for example, now make a change to the filter list and have 30K of the changes at the same time, we will probably get notified very quickly in the Sentry, like right away from the user's devices, that something's wrong and we need to tackle that. And then we start investigation. Is it because we updated the extension, or is it because div update happened because the filter changed? And that's how we proceed.
Okay, good.
I wonder more about the data gathering you mentioned earlier about the DNR rule sets, the number of DNR rules in the browser and the actual rules you have. Did you had to deploy a new version of extension to gather those data, or you just have it in prior it happens?
Well, to be able to gather those data, we had to deploy new version because we had to enable the module itself to start logging, because the code for logging is usually surgically set in the specific places of the code that we want to track. So it's not like spread it everywhere. If we need it, we start looking what data we need, what flow we need to track, and then we deploy the version of the extension that has logging enabled or has a possibility to enable the logging. But then there is also the feature flag system, which is all the time in the extension. And if we connect it to the feature flag, then we enable this logging only for the percentage of the users, and we can modify the number of users that we get the data from. So there are two systems working together, complementing to each other. So we are not fully flexible to enable logging wherever we want remotely. We need to deploy the changes in the code, but at the same time, we can decide how many users can be affected by logging. So if it's enough for us to use 1%, if we see data that we don't need to go up. But if we see that it's working or we get not enough data because we don't have so many affected users, we then extend the sample rate or the number of the users that we want to get logging from. And then for turning it off, again, we don't need to do it because we can limit it to 0%, but we want to have clean code. So at some point, we also clean the logging from the code and release new version without this logging in this module.
Yeah, what I wonder was the effectiveness for the time to fix. For example, if you deploy the logging system, after the incident happens, that means you need to wait about 2 weeks for the extension to be released on the marketplace. And for the fix, you take another 2 weeks for web stores to release the new version of extension, and you roll out after that. And it doesn't that mean you took over a month to fix the issue completely?
Well, the 2 weeks is the normal cadence that we have for the extension. So we do the cadence of 2 weeks between the extensions because we want to have, we don't want to reach the limit with the DNR rules, like the number of DNR rules in the diff updates. That's why we do it so often. And that's the regular situation. But whenever we do the debugging or whenever we see that there is an issue, we can release it right away. We don't have frozen time because we have automated tests. So at the moment when we have a fix or logging enabled, we can release it. And then it's up to the browsers how quickly this can get to the market, which usually takes 2, 3, maybe 4 days, depending on the browser. And then we can start using logging and seeing the logs on the server. So it's not 2 weeks. This is not enforced by anyone outside. It's like regular cadence. But if we need, we expedite it, we release it much more faster, and then we can iterate much more quicker.
Oh, and another question would be regarding the filter list crawling and the validation with the filter list maintainer. If I recall correctly, Alpha Plus has their own separate regional lists in their own repository. For example, like Alpha Plus Korean or whatever, apart from the EasyList, regional EasyList filters, like EasyList China.
Yeah.
Does that mean that filter list maintainers write the filter and push it to the repository, and they got alarm from themselves and validate themselves again with the screenshot?
No, as far as I know, they have their own tests on their site, so they are running their own test before they push it to the repository. Of course, one of them is also validating the syntax of the errors, the filters, checking the errors in terms of the filterless crawler. So that's, as far as I know, that's one of the steps. So usually we don't get into that loop that we are pushing something and fixing. Usually we test it locally because we have this tool already in-house, so we can use it. But we also want to make sure that the community filter lists are healthy and that they are effective. So that's why we also use it on a wider filter lists.
So the validation happens before you push to the production, if I understand correctly.
Yes, of our filter lists, yes. Of the filter list from the community, we need to validate it on the extension ones, because you can have your custom filter list, and we also have validator in the core that we run the validation there.
Oh, and do you have any special lists allocated only for those kind of validation, apart from the filter authorization?
I'm not aware of that, but I can check and reach out to you later on, because as I said, I'm working mostly on the extension side. I wanted to include the filter crawler here because I think it's interesting to look from the different perspective as well, but I didn't get into more details on that.
Thank you for the answer. It was really interesting talk. And
Yeah. All right. And thank you, Aga.